It's going to take a little. I think it should be running. Yes. Yeah, you see the boot up. I may have gone too far, actually. I may have hit it twice. I think I hit it twice. Okay, not too far. So this is it. So I can stop it. Now, anyway, we're just here at this point. I'll try again. Do a reset. Do another reset. So now the breakpoints after my reset are enabled again. I can disable this one. I may not want it now, but instead let's start kernel and do a run and see if we hit it this time. Now sources and search paths are set up. It should find the correct location and stop.
So process right.
Right. So here we are at the start kernel function. And now we see a lot of things have changed here in the registers. For example, here you see the instruction pointer at the start kernel function. Now what I want to show you here is the control registers. This is what I mentioned this morning where we have this famous bit field editor. You saw that there were also changes before we reached this source line. So if I do if I want to look what is in this register, I can look at these things. Here, for example, you see now when I click here, this bit gets flipped, and here you see what it means. I'm flipping it from protected mode, enabled, to disabled. So you can really do awful things with no comments, no barriers, no "Are you sure?" There's no network or security built in here. You can flip all sorts of things.
How do you keep track of what you've done?
No. I mean, I can restore. I can restore here.
Yeah.
Okay, so I'm not gonna.
But what I'm getting at is that if you're trying to debug something, you need to have a sort of structured approach to the changes you're making and what you're doing. And it seems to me it's awfully like people who used to debug COBOL, or they sit at their pad, so sit in front of a screen and type away and automatically find all possible bugs. And we found out it was actually more effective to come up with a test plan and execute a structured test plan. This looks or feels like it's going back to somebody bright sitting in front of a piece of hardware and trying things to see whether they work. And then you need to keep track of how much coverage you've done, how many different options you've made.
Yeah, well,
does that make sense?
Sure. Yeah, I mean, what you can do is you can write a log file while you're debugging.
Yeah.
So in case you're losing track, you can start from the beginning, reload the log file, and execute the same steps that you already did up to the point where you broke off. But once you're in this area, I mean, what you're actually doing here is what you might have otherwise in an assembly source file that just fills registers with bit patterns.
Yeah.
Now, I doubt if you can keep better track of changes by changing a source file and recompiling it and loading it.
Last time I did stuff like this, it was looking for bugs in the database. I kept track by having basically printouts and looking at the way the registers changed from one printout to the next.
Okay.
So you
Yeah.
had a permanent record. It was long and slow, but
Yeah, I mean,
it leaves you get confused.
maybe I'm getting too, I mean, I'm making too much of a fuss of this one. You really, you're not going in randomly here and playing with bits. Some are also locked and you know, you cannot change. They're more for information, so, or they are read-only. There is some system IDs stored in there. So all I'm saying is here, once you know what you're doing, and if you, for example, if you flip a bit, or you set one bit wrong in the initialization, you can do it on the fly here in debugging once you're sure what you're doing, instead of going through the whole cycle and recompiling, uploading, starting a debug session. I mean, that's about it.
Yes. But on that hand, though, I'd have thought that it's possible to go through and think you've tried flipping that bit in register 13 or something, and you forget to do it. And because this is a fairly, I would like to see a log, not just a log file of what you did, but also perhaps a utility that runs against that log file and gives you a structured or a visual representation of what you were doing, just so you can keep track of what you know, when you come back next day, you can actually help you remember. Or people that do this have wonderful memories and never forget what they've done.
Yeah, maybe making a screenshot and dumping it in a Word file or a text file is the way to do it. And I mean, it's.
Well, I was wondering whether you actually had tools to help you do that.
No, we're not doing that on that level.
No.
I mean, the nice thing here is that remember, you may have hundreds, virtually, really hundreds of registers like this with these processors, peripheral registers. And here you have all the documentation with every bit pattern and bit groups in these registers. So it comes in very handy to know what you're doing instead of flipping through tons of books to understand what. So I guess the likelihood is higher that you hit the right bit here than if you try to do it in another way. I guess that's about what we can offer here.
And are you sure that these emulators, how are you sure that the emulated behavior which you're developing to is the same as the behavior of the real thing in a production environment, actually inside a phone? Because you're developing a software here on an emulated or simulated phone, aren't you sometimes?
No, I mean, this is not a simulator.
Okay.
I mean, this is the processor with hardware
it's
access
just outside of
to
its
the real thing. This JTAG port usually is removed once you go into production because no phone vendor wants anybody else to hook up a JTAG debugger and look into their processor and their software. I mean, their system software.
Yeah. So that's the real thing with just an extra port on it.
Right. There's this extra port that you usually have on the development boards and that get removed. Which makes it hard, of course, once you're in production and you hit a system problem that requires system debugging, then you have a hard time because you don't have this access anymore on the small form factor.
Do you have access to the PCI configuration space as well?
Yes, there is. We have system registers, processor model, and system controller registers. So we have system controllers here. We have the PCI registers. So there's a description here, and whatever, see what's in there. Some of these things you can change. Only
the Intel ID, yes.
Yeah. So yeah, that's what I meant. This is all these registers that you have here for each of the devices, and there's more and more. What can be devastating is if you have this register window open and start running your program at a time when these are not initialized, and you get into nirvana usually. Or it takes forever because it keeps trying to update them.